Okay, so we're going to continue on with talking about scientific notation, and we're moving from converting to scientific notation into standard form. So last time we did standard form into scientific notation. Now we're going the other direction, and then we're also going to talk about ordering, or how do you order scientific notation. So let's go to our paper, Math Interactive Notebook, and you want to write down as your TOC. We're still in 1. And converting scientific notation into standard form and ordering numbers in scientific notation. And I'm going to be on page 11 in my notes. Of course, if things have been taking you a little bit longer or more pages to do, then you want to mark that in your TOC accordingly. So again, converting scientific notation into standard form and ordering numbers in scientific notation. Okay, again, I'm going to write it on a flat sheet of paper here just to make it a little bit easier for the writing and the reading and all that good stuff. So imagine that you're on page 11 in your Math Interactive Notebook. And at the top, we're going to write converting from scientific notation into standard form or a standard number. This is beginning on slide 59 in your digital notebook. Okay, so what are the steps to convert? Okay, so step number 1 is to look at the exponent of the base 10 determine which direction, right, left or right, the decimal will have to move on the factor, right, or coefficient. I like the word factor more than coefficient, but some people call it the coefficient, even though there's no variable afterwards. So that's step 1. So for example, if you have a number line, right, just envision a number line. This is what you should be envisioning in your head. And here is 0. We have 1, 2, 3, 4, -1, -2, -3, -4. If your base 10 had a 0 exponent, it wouldn't move at all. Like your factor would just be what it is, right? Because we know anything to a 0 exponent is worth 1. So that would be like having your factor times 1. So that wouldn't change anything. If you have an exponent that's positive, right, that means that we have to add value back in. So if it's a positive exponent, right, it's moving, your decimal will move to the right. And if it's a negative exponent, your decimal is going to move to the left. So step 2 is to move the decimal of the factor or coefficient the direction and distance determined in step 1. Now you notice I didn't talk about distance up here, but your distance is whatever the exponent is. So if it's 4, you're going to be moving 4 places, whether that's a positive 4 or a negative 4. You'll be moving 4 place values. But which direction you move is determined by that sign. So if it's a positive 4, you'd move 4 places to the right. If it's a negative 4, you'd move 4 places to the left. So let's look at what else we may have to do. The other last thing we want to write here. So that's determined in step 1. Fill in empty places with 0 or zeros. So what does that look like? Say I have 3.1 times 10 to the 3rd power. Well, it's telling me to move 3 spots. It's positive, so I'm going to move to the right. So if I took 3.1, I'd have 3, 1, and then I have a place and a place, right? That's what I'm going to need. So those additional places I need, I'm going to fill in with zeros. So I moved, I was originally here, 1 place, 2 place, 3 place. If we had 3.1 times 10 to the negative 3rd, right, I have 3, 1. This is 1 spot, so this was 1 spot, and I'd need 2 more spots before my decimal. Kind of like a thing to keep in mind, because if you're doing a negative exponent, right, and there's only 1 digit in front of the decimal all the time with your factor, you're going to have to add in some zeros between the decimal and your first non-zero number, right, or your first significant digit. So the way you determine that is just, well, this was 3, negative 3, but I was going to move 3 spots, and we can see here 2 wind up being zeros. So on the negative exponent side, it's always going to be the number of zeros, so it's always going to be 1 less than what this number is. So if I had 4.2 times 10 to the negative 4th, 1 less than 4 is 3, so I'd have 0.00042. 1, 2, 3, 4 spots. Here, 3.1 times 10 to the 4th, 3, 1, 1, 2, 3. And the only reason that applies just to the negative number is because up here it may not always be 3.1. What if it's 3.126? In that case, I'm not going to have to add in any zeros if I was only moving at 3 places. If I was moving at 4, I'd only have to add in 1 zero. So that's why it's more significant with the positive exponent than the negative. Now let's talk about ordering exponents. So this is going to be on slide 63 in your digital math interactive notebook. So how do we order numbers in scientific notation? And I mean, of course, one of the options would be to convert all numbers into standard form and then just put them in order. That's an option. But it goes back to mathematicians being efficient, and we want to do the least amount of steps possible, because the less steps, the less likely you are to make an error. And with ordering, sometimes you're going to have scientific notation mixed in with standard numbers or other rational numbers, radicals. It could be all different kinds of things. But just remember that if we were looking at a number line, this number here, 31,000, if this was on a number line, right above it could be 3.1 times 10 to the fourth. Remember, these two things represent the same value, right? So how are we going to order? Well, there's some steps we're going to follow. Step 1. Identify an exponent close to 0 among the scientific numbers you want to put in order. Put that need to be ordered. And in this step, the reason why we do that is we're going to change all base 10 exponents to the chosen exponent by moving the decimal of the factor. Okay, so what does that mean? So if I had, we'll say 5.123 times 10 to the 7th. So if I had 5.1123 times 10 to the 7th, this is in scientific notation, okay? Part of what we're going to be doing here is taking numbers out of scientific notation, but not all the way. So we're going to be changing it to somewhere in between scientific notation and standard form. Things to keep in mind: 5.123 times 10 to the 7th, that is equal to 51.23 times 10 to the 6th. See, by decreasing one spot, I moved my decimal over one to the right. I can keep on doing that, and that would be equal to 512 times 10 to the 5th. And I can keep on going all the way out to I have no more base 10s left. I can even go the other way and make it equal to 0.5123 times 10 to the 8th. So I can change the value. It's not going to keep it in scientific notation, but for ordering, I don't necessarily need it in scientific notation yet. I'm just trying to figure out what number is the largest versus what number is the smallest. And the easiest way to do that is to compare apples to apples, right? And if the numbers all have different base 10 exponents, that's apples and oranges. We need them all to have the same exponent, so then they're all apples. So then step 2 is to determine the order based on the factor coefficient. So imagine if we had 25.13 times 10 to the first. And then we had 0.8712 times 10 to the third power. And here everything isn't going to be in scientific notation. That's okay. 0.073 times 10 to the fourth power. And 87.3 times 10 to the second power. And someone said, well, which number is the largest? Right? So we had 25.13 times 10 to the first, 0.8712 times 10 to the third, 0.073 times 10 to the fourth, and 87.3 times 10 to the second. Now, of course, I could have, gone through and said that this is, 8,712 thousandths and 73 thousandths and 87 and 3/10ths and 25 and 1300ths. But I just thought using the decimal and the digits would be a little bit easier for you guys to understand. So according to this, I want to pick a number that's close to 0. So I'm going to go with the 1. So this one is not going to have to be changed. It's going to keep the same 1. And here's the thing. You want to pick an exponent that's in the bunch that you're trying to order. Like, I'm not going to go ahead and pick 0, right? Because that would just be changing everything back to standard form. I'm not going to pick 5 because no one's at 5. I mean, I could, but it just makes sense to at least have one number that I'm not changing. So here, if I want to make this a 1, I'm going to have to move that decimal 2 spots to the right because I'm getting rid of 2 of the positive exponents. So this becomes 87.12 times 10 to the first. Here, the difference between 1 and 4, 3 spots I'm going to have to move. So this becomes 73 times 10 to the first. And you notice that 0 in front falls off because I'm not going to put 073. That 0 is no longer a significant digit when I move it. And lastly, this is to the second power, so I'm going to move it just 1 spot. So looking at these, I can clearly tell now that this is the biggest number, right? Or the most, or the greatest. So this, if I was going to put it in order, this would be the biggest, and this would be the least. So that would be the 4th spot. And if I kept on going, I would go, this would be number 2, and then this would be number 3. So in order, the greatest number, if I was going most to least, would be 87.3 times 10 to the second, followed by 0.8712 times 10 to the third, followed by 0.073 times 10 to the fourth, followed by 25.13 times 10 to the first. And you'll notice that the exponents, it wasn't as easy as going to the biggest exponent, right? That wouldn't have worked out for me, actually putting them in order. So that is one of the methods you can use for ordering numbers in scientific notation. And that's the notes for today. This, did we put on there? Yes, slide 63 for ordering, slide 59 for converting, and you have your GPs that you have to do your guided practice in there as well.